Hi there. Today, I would like to welcome you to Naval Horizons. I am Pam Jocelyn from the Albert Einstein Fellowship. I am with the Naval STEM Coordination Office. Today, we would like to welcome Dr. Treva Brown with us today. Treva, thank you for joining us today. Could you tell us more about your title and what is it that you do?
Yes, so I am a physical scientist at the Naval Research Laboratory at Stennis Space Center in Mississippi. And a physical scientist is basically someone who looks at the physical properties of things, and I do that by utilizing a microscope.
And Treva, could you tell us a little bit about your background and how did you get to where you are today?
Definitely. So I started my career at Louisiana State University with a bachelor's degree in chemistry. Then I went on to get my PhD at the University of New Orleans in inorganic chemistry.
This is quite the jump. And so to go from organic to inorganic. And
Definitely.
Then, so what brought you to the Navy?
So this is an interesting story. So what brought me to the Navy was I was actually found in grad school, if that makes sense. So by that, I mean recruited. And while I was in grad school, a person from the Naval Research Laboratory reached out to my research advisor and asked about me. And what they were looking for in particular was someone who did microscopy work, so someone who worked with microscopes. And from there, I went on to go to the Naval Research Lab, and I've been having fun ever since.
So when you study microscopy, what exactly are you looking at and looking into?
So I am looking at really, really small things. So I like to tell people, especially students, if you think about one strand of your hair and being able to see the follicles of your hair strand, that is how minute we can get in a microscope to actually see all of the fun things around us, especially with microorganisms.
Nice. And so you're doing this with inorganic now, though, instead of microorganisms?
So actually, interesting topic as well. So I'm actually combining the two. So working with inorganic chemistry, so inorganic being everything that is not living. So if we break it down, organic is living, anything that's breathing, inorganic, everything else. So combining that with corrosion research, which is where the inorganic background comes from, and then the microorganisms come into play because I study the microorganisms that actually cause corrosion. So I have to look at my microscopes to be able to see these little tiny microorganisms that's causing the large-scale corrosion that we're seeing on the assets that we study.
Nice. And so is it specifically like bacteria, or are you looking at different algae as well when you're looking at that corrosion?
Yes, so I look at everything. So algae, bacteria, fungi, also barnacles, diatoms are my favorite because they are this diatomaceous earth that are these perfect symmetrical little beings that I can spend all day just looking at those because it's amazing how these things form so naturally, but the only place you can see them is on the seafloor.
Could you tell us what a diatom is?
Yes, so diatoms are this natural phenomenon that happen under the pressures of the ocean. So we know that as we go deeper with down into the ocean, the depths, the pressure increases. So as that pressure is increased, it's almost similar to how we make a diamond. So the increase of pressure, we of course are able to crystallize a material, and that's a diamond. So similar to a diatom. So that increase of pressure causes these amazing symmetrical organisms to form at the bottom of the ocean due to those high pressures. And so when you look at them under a microscope, the symmetry is amazing. So we know that we as people are asymmetric, but diatoms, when you see them, they just make this beautiful geometric symmetry that is just amazing to a microscopist to look at.
Yeah. How do you relate what you do to the average high school student?
Oh my goodness. So I have to say that living in the environments that we live in, and especially in Louisiana and Mississippi, there is water all around us, right? So when we think about the Navy, we think about ships primarily. There's other aspects related to the Navy, but we think about different things being in the water. So to the high school student, I would challenge them to look at different metal things around them. Look at how water is actually causing those things to transform in the form of corrosion. One of the examples I like to use at home is when you think about your car. If it's inundated in any way, meaning if you have an accident, a wreck, if you scratch the paint off, you are taking away that protective layer that is on top of the metal that makes your car. And if you leave it unprotected, over time with the water and the weather, you will see corrosion. So I always challenge students to try to take a little piece of that corrosion and look at it under a microscope and see all the fun little organisms that are going to be attached to either that corrosion or that piece of metal, and you're going to be able to actually see the science and see what corrosion actually is.
Nice. Do you broaden that and have it look like, for example, at soils with corrosion or even gases in the atmosphere too?
Yeah, definitely. And actually, some of the projects that we have in the laboratory, we actually bury some of our samples underground. And then when we dig them up, we look at what organisms are actually causing the degradation or the basically breaking down whatever it is that we've buried underground. And then when we think about the gases, one of the things we think about is, the emissions from fuel systems, right? Mm-hmm. And so that even causes corrosion as well.
Nice. Thank you.
Yeah.
You touched a little bit about the Navy. Could you talk a little bit more about how does your research impact the Navy?
Yeah, so definitely. So a lot of people ask, okay, so you study corrosion, we have corrosion all around us. But for the Navy, it is of great interest in particular because we have assets. So assets meaning our helicopters, our air carriers, our naval carriers, our big ships, our floating cities that are in the water carrying our men and women that are being of service to this great nation. And one of the things that we have to do is protect those assets. And corrosion is a big problem because these assets are operating in water all of the time, and the water has salt contents in it, and those salt contents vary. And with salt and with also living organisms being in these waters, it is just a great way to start and have corrosion, and corrosion will always be around us. And so the work that we do with corrosion is trying to help keep the corrosion at bay. It's going to happen, but what can we do to continuously fight against the corrosion that's going to happen? Because we have to always continuously operate in these waters. So the corrosion piece comes in because we're always in water, and the microscopy piece comes in because there's all these little microorganisms that want to eat away at these metals, and we don't want them to eat away at them. We want to be able to keep them in the water where they should be, but we also have to figure out how can we keep them away from our metal ships as well.
Nice. So are you changing materials, or do you ever look at material science with the corrosions as well?
Definitely. So we look at the different metals that are available. We look at ways that we can combine these metals, which is called metal alloys. We also look at ways that we can use top coats, primers, and paints to mitigate against corrosion too.
Nice, thanks.
Yes.
So Treva, you shared a lot with what microscopy is used for today, but what does that look like 15, 20 years from now?
Definitely. So microscopy is ever evolving. There are so many different types of microscopes out there. So I work primarily with what's called scanning electron microscopes. And basically what that is a microscope that scans the surface of a sample. And as the observer or the scientist, I am able to tell what is there on the surface of that sample. There are also other microscopes out there where you can do cryogenic microscopy, meaning you can freeze samples, and that's what we also like to do, being that we look at microorganisms because they're a living thing. And in order to be able to view them, sometimes we have to freeze them to protect the integrity of the microorganisms, because under those microscopes, it's so much high energy that sometimes they can just kind of ablate or just just not be there. And so the technology is ever evolving. We have an entire microscopy conference where we learn about all of the different technologies. And it's going to continuously be an ever evolving technology because we want to see down to smaller scales constantly. Things are always wanting to be smaller, right? So we have all the different types of technologies to try to look at any and everything that we can possibly look at. So the smaller, the better, but also considering the properties of the different materials. So when you think about a living cell compared to a metal, there's different types of microscopy that you have to use to figure out what's going on with that. So we're going to continuously ever evolve. The instruments are going to get bigger and bigger, and the technology to see those different things that we want to see as scientists is going to continue to get smaller and smaller.
Yes. Do you have a favorite story? Like, what's your favorite day?
Oh my goodness. So I'm going to give you two different stories, okay? So my first story will be what got me here. What made me want to become a scientist? And that story for me, I always say it's my why. What keeps me going? And my why is when I was actually doing science outreach, I met a young girl who was astonished that she met a scientist that looked like her. And from that moment on, I had to continue being that representation that I wanted to see, which is my mantra: be the change and the representation that you need to see. So that is definitely a story that I carry with me all the time. Now, in the lab, one of my favorite stories is we were doing a cleaning study in the lab. And one of the things that we did was we wiped off this particular metal with some isopropyl alcohol. So similar to rubbing alcohol, but a little bit stronger. And this was known per literature that it's supposed to take off the fungal growth that we were seeing on this particular metal. Well, when looking under my microscope, I happened to find the exact same spot that I wiped off with the IPA is the acronym, with the isopropyl alcohol, and it wasn't clean. And this just spearheaded an entire research project that I actually am still working on, but that is my favorite story so far that I have in the lab, being able to discover something that just transformed into this entire project.
Do you have advice for any young high school students who want to enter the STEM field?
Definitely. I would say to not be afraid of it, as I was. So I was a first generation college student, college graduate, PhD student, and PhD graduate. And I was scared of it. I thought that I was not smart enough, which I came to learn that meant I was kind of suffering from imposter syndrome. So imposter syndrome means that you just don't think you're good enough for something. You don't think that you belong in the same room as some of the other greats that you might look up to, like me. I looked up to a lot of people, and I'm like, there's no way that I could be sitting in the same room with this amazing scientist. Like, do I belong here? Well, I'm here to say that yes, you belong. So to any high school student considering STEM, I would say to go for it, no matter what obstacles might come in the way, because unfortunately there will be obstacles. Find a mentor. Mentors were my saving grace. Without my mentors, I don't think that I would be here. So a great mentor is one that will follow you through every step of your journey, especially in the STEM processes. It took one of my mentors that was my undergraduate research advisor. She took me under her wing and she taught me about research. She taught me about microscopes. She taught me about going to graduate school because I didn't even know what a PhD meant. I didn't even think I would get a PhD. So mentors, having that support system, and just not being afraid of it. Have fun with it. Like, I have fun with it. I love jewelry, and jewelry is the reason why I got into science. And I started my first research project with gold because I like jewelry. So find a way that makes it fun, make it your passion, and you'll definitely be able to succeed.
Awesome. You're great role models, so thank you.
Oh, thank you.
I would like to thank you, Treva, for joining us today and sharing your story. And I would like to invite everyone else to watch more Naval Horizons videos. Thank you.